Hello, knowledge seekers. In this episode of 20-Minute Books, we unpack the riveting pages of The Future of Humanity by Michio Kaku. As we delve into this 2018 masterpiece, we embark on an awe-inspiring journey that transcends the boundaries of Earth, venturing into the vastness of space to explore our potential new abodes on foreign terrains. With the precision only a physicist of Michio Kaku's caliber could offer, this book is not merely a foray into speculative wonder, but rather a serious contemplation of humanity's next grand chapter. Through Kaku's insights, we learn that the once fantastical idea of colonizing other planets is swiftly evolving into a tangible project for scientists and visionary entrepreneurs alike. He artfully navigates through the current endeavors, groundbreaking technological advancements, and crucial problems nearing resolution that could pioneer our species' interstellar migration. Michio Kaku, a prodigious futurist and esteemed professor of theoretical physics at City University in New York, brings his formidable expertise to the table. As a correspondent for CBS and the engaging host of various radio and TV science programs, his reputation is bolstered further as the author of acclaimed publications such as The Future of the Mind and Physics of the Future. The Future of Humanity is essential reading for a broad spectrum of enthusiasts, from those enamored by speculative science, students immersed in physics and planetary science, to the dedicated stargazers who find solace in the night sky. Join us as we explore how close we are to reaching the stars and what marvels and trials await us in the cosmic pursuit of our survival and prosperity. The Future of Humanity, Terraforming Mars, Interstellar Travel, Immortality, and Our Destiny Beyond Earth. Introduction. Embark on a journey to the stars and envision humanity's cosmic future. Picture this: humans navigating the vastness of space, living on distant planets, and converting the once fictional into our reality. The essence of science fiction is slowly crystallizing into tangible possibilities, as visionaries and moguls pour their fortunes into constructing a future that many of us have only dreamed of. Imagine spaceships not as vessels of escapism on a silver screen, but as intricate networks connecting Earth to cosmic neighbors like the Moon and Mars. The impetus for such ambitious endeavors is no longer just the stuff of daydreams, but has taken root in the investments and innovations of our time. Resilient communities adrift in space and terraforming, inhospitable planets into Earth-like sanctuaries are goals within reach, with advancements in nanotechnology and artificial intelligence propelling us closer to these frontiers. Our exploration today paints a picture of this phenomenal odyssey, exploring the structures and sciences that will pave our path among the stars. In our narrative, we'll explore the potential use of ancient Martian lava tubes for human habitation, the promise of carbon nanotubes in building future off-world colonies, and the intriguing concept of light sails that might navigate the cosmic seas to humanity's next abode. Prepare to set sail on an adventure that stretches beyond our blue planet into the unknown realms where our future among the galaxies awaits. Part 1. A century of passion ignites humanity's rocket-propelled dreams. Space exploration is no longer the exclusive domain of governmental giants. Private entities like SpaceX are drawing eyes skyward, charting commercial courses to the cosmos. Yet, the quest for the heavens goes deep into our past, spanning over a lifetime of scientific fervor. Rocketry's pulse began to quicken long before the mid-20th century's frantic space race set the United States and Soviet Union on collision courses with destiny. It harks back to the intellectual curiosity of a visionary Russian scientist, Konstantin Tsiolkovsky. In the year 1903, Tsiolkovsky penned an equation that redefined rocket science. The Tsiolkovsky equation offered a glimpse into the previously unfathomable, defying Earth's gravitational clutches with methodical precision. With this mathematical gem, Tsiolkovsky shone a light on the fuel-speed conundrum. empowering scientists with the knowledge needed to reach celestial bodies like the Moon and Mars. The blueprint laid by Tsiolkovsky paved the way for American innovator Robert Goddard, who ushered in a new era of propulsion. Goddard's leap from solid to liquid fuels, and his design of multi-stage rockets, a system of shedding spent fuel tanks to reduce dead weight, were nothing short of revolutionary. As the 1940s unfurled, another figure emerged, Werner von Braun, a physics prodigy, ensnared in the throes of Germany's dark rearmament under Nazi rule. Launching headfirst into rocketry, he had little interest in the politics. His eyes were on the stars. As the leader of the V2 project, von Braun had vast resources at his disposal, birthing a rocket that soared at thrice the speed of sound, immune to the era's air defenses. Despite its record-setting technological triumphs, the V2 would unleash its fury on the cities of London and Antwerp in 1944, leaving a grim legacy. Ironically, the very scientist who inadvertently fueled conflict with his creations endured the sting of the Gestapo's suspicions and faced the harsh reality of the labor camps that built his rockets. As von Braun grappled with the consequences of his work, he would later become a pivotal figure in the international sprint towards space, an odyssey powered by mankind's undying infatuation with rocketry. Part 2. A return to the moon beckons in the modern era of space ambition. The 1960s witnessed humanity's monumental leap, the lunar landing. It was a time when the United States, spurred by early Soviet triumphs in space, channeled its resolve to etch its name on the moon's surface. The Soviet Sputnik, the world's first satellite, and Yuri Gagarin's historic orbit around Earth had sounded the clarion call. The Apollo 11 mission, graced by the likes of Neil Armstrong and Buzz Aldrin and powered by the immense Saturn V rocket, Werner von Braun's brainchild, etched July 1969 into the annals of cosmic history. The race to the moon had found its victors. However, the 1970s saw a shift in priorities. Social challenges and the Vietnam War pushed grand visions of space exploration into the margins of America's collective consciousness. The present, however, tells a different tale. Space is once again in vogue, and this resurgence of lunar fascination is bolstered by the dreams and deep pockets of billionaire entrepreneurs. Take, for example, Blue Origin, a space venture spearheaded by Jeff Bezos of Amazon fame. The New Shepard rocket system, while not built for lunar expeditions, could usher in an age of commercial space travel. Yet, Bezos eyes a loftier prize, colonizing the moon glow. His 2017 proclamation of establishing a lunar supply line plants the seeds of a future where the moon might shine not just with celestial light, but with the glow of human habitation. The moon, as humanity's secondary abode, stirs the imagination, but numerous obstacles await. As we delve into what's next, we'll ponder the formidable challenges that must be overcome if we are to call the moon our home away from home. Part 3. Conquering the moon's harsh environment is a complex challenge. Victories in space travel have been celebrated, but the true odyssey begins with transforming the barren lunar landscape into a realm suitable for human life. The critical triumvirate for sustaining life, air, food, and water, poses questions we've yet to fully answer on the moon's surface. Breathable air, a treasure we take for granted on Earth, is absent on the moon. The lack of an oxygen-rich atmosphere means we must devise ways to produce or transport this life-sustaining element. Promisingly, we can turn to known chemical processes to extract oxygen from lunar water and soil, like turning the moon's hidden reserves into breathable air. Unveiling an estimated 600 metric tons of ice at its north pole, the moon hosts this vital commodity in shadowy craters and behind towering mountain ranges. And from this ice not only can we quench our thirst, but also derive a bounty of oxygen. Where there's oxygen, there's potential for agriculture. The lunar surface, initially barren, could one day blossom with crops nourished by the constant solar embrace. For generating energy, the power of the sun once again plays a crucial role. Peaks near the moon's poles, kissed by never-ending daylight, are prime locations for solar panels soaking in endless energy. Yet, with the sun's blessings come its curses, the relentless march of cosmic radiation, a scourge to any would-be lunar inhabitant. Unprotected exposure could pave the way for cancer, among other health woes. Our countermeasure may lie in the moon's subterranean scars, the lava tubes from a volcanic past. These ancient caverns could provide a shielded haven from the sun's harmful touch and offer a secure sanctuary for budding lunar societies. The celestial body that has serenaded humanity for eons with its silver glow and haunting beauty asks us to solve a complex puzzle. But each step towards addressing these crucial needs brings us closer to planting the seeds of human life upon its soil. Part 4. The Red Planet beckons. SpaceX gears up for Martian metropolises. Elon Musk of SpaceX and Jeff Bezos of Blue Origin, both visionaries enamored with the cosmos, are charting paths to celestial bodies, yet their sights are set on different horizons. While Bezos gazes at the moon, Musk's eyes are fixed on the rust-hued surface of Mars, his dreams spinning tales of a multiplanetary species with colonies beyond Earth. SpaceX is not just dreaming big, but also redefining space economics with its innovatively reusable rockets, shattering the old paradigm of expensive single-use boosters. This reusability slashes costs dramatically, a disruptive transformation reflected in their groundbreaking payload pricing, $1,000 per pound, as opposed to the staggering $100,000 status quo. The narrative of SpaceX unfolds in earnest, with unmanned missions to Mars slated for the near future and crewed voyages penciled in for 2024, propelling the company beyond NASA's own Martian timeline by half a decade. Musk's ambitious tableau paints a city on Mars, thriving under the glow of solar power and built by an ever-expanding cohort of interplanetary pioneers. This is not merely a quest for new landscapes, but a leap towards securing humanity's continuity across the solar system. Yet, dreaming of Martian cities is no trivial fantasy. Mars confronts us with an array of daunting hurdles. Its thin veil of an atmosphere laden with carbon dioxide and pressure a mere sliver of Earth's creates a world where the act of boiling could occur at treacherously low temperatures. In such a realm, a breach in a spacesuit stands between an explorer and their blood turning to vapor, prompting a need for impeccable protective technologies. Moreover, Mars's gravity, or lack thereof, poses a threat to human physiology, evolved for Earth's unique tug. The specter of bone and muscle atrophy looms over would-be Martians, necessitating rigorous daily exercise just to maintain health. This is the challenge of Mars, a world that tests our resolve with every grain of its regolith. To thrive there, we must innovate and adapt, ensuring our species' long-held adaptability extends to realms beyond the nurturing cradle of Earth. To settle Mars is to evolve once more, to rewrite what it means to be human in the unyielding expanse of space. Part 5. Conquering Outer Space with the Marvels of Nanotech and Robotic Pioneers. Contemplating the construction of a Martian metropolis, one might rightfully balk at the astronomical costs such an undertaking would incur. Traditional methods, reliant on terrestrial labor and materials, would be prohibitively expensive. A financial gravity well that not even NASA or rich nations could easily escape. The innovation lies not in resources, but in the realm of the minuscule, nanotechnology. One contender for this monumental task is graphene. A marvel of molecular engineering, graphene consists of carbon atoms forged into ultra-thin, ultra-tough sheets. Its strength? A staggering 200 times that of steel. Rolled into carbon nanotubes, these sheets could become the backbone of extraterrestrial infrastructure. But graphene's potential extends beyond mere sturdiness. It's a conductor of electricity. The catch is that we must learn to produce it on a massive scale, free of the impurities that could compromise its properties. Today, we can craft only postage stamp-sized pieces, but with the relentless march of chemistry, This next century may well see our capacity to mass-produce graphene come to fruition. When it comes to erecting the future landmarks of Martian cities, artificial intelligence could hold the key. Envisioning construction in such hostile environs brings to mind the 3Ds, jobs that are dirty, dull, and dangerous, suited not for humans, but for AI-driven hands. These automatons, robots with brains, would tirelessly labor through the tasks we dread, never wearying under the red glare of the Martian sun, scouring lava tubes, braving extremities of temperature, and resisting radioactive onslaughts, all within the capabilities of these mechanical trailblazers. AI, while not yet at the zenith of sophistication, is on the ascent, promising a future where automatons might serve as the flag bearers of human extraterrestrial expansion. Humankind stands on the threshold of an era where our mastery over the microscopic and our command of robotics could liberate us from earthly shackles. In this dance of molecules and machines, we find hope, a future of space-borne cities woven from the fabric of ingenuity, rooted in the science of the small, and built by hands not of flesh, but of unyielding metal. Part 6. Exploring the vast universe with nanotechnology's tiny titans. Our eyes have long gazed upwards, pondering what celestial secrets lie beyond our terrestrial home. Among the stars, we search. Could there be another Earth waiting in the vast ocean of space? Emerging from the realm of the infinitesimal, the nanoship offers a glimmer of hope in our quest for cosmic kinship. Envision a vessel no larger than your thumb, bristling with sensors within a microchip, poised to chart the unknowable void. These nanoships employ light sails, delicate membranes that catch the stream of photons, whether from our sun or potent lasers. This propulsion, bereft of cumbersome rocket fuel, would send these diminutive explorers dashing across space at unheard-of velocities, with the moon a mere 5-second jaunt away. Alpha Centauri, our stellar neighbor, a mere 4 light-years distant, offers a tantalizing target. A nanoship might bridge the cosmic gulf in 2 decades, bearing Earth's inquisitive spirit toward this natural port of call. But let us not leap too quickly. Challenges loom large. Power, vast, nearly unimaginable amounts, is the first hurdle. A nanoship's journey to Alpha Centauri demands a 100-gigawatt beacon, dwarfing the output of our mightiest nuclear plants. Such an endeavor could bleed NASA dry without a philanthropic savior or government largesse. Precision stands as another titan to tame. Miss the mark by a fraction when aligning laser to light sail, and our nanoship becomes a celestial stray. Compounding matters, Earth's atmosphere devours half the laser's might before it can kiss the sail. The moon, with its airless expanse, beckons as a waypoint freed from terrestrial challenges. Perhaps laser stations and nanoship launch sites shall crown lunar craters, drawing from solar arrays that bask in eternal light. Here, among the dust and silence, automatons could toil, tending a nursery of light that births vessels into the dark, an eternal testament to human reach and robotic precision. Within these miniature emissaries lies the potential to unfurl humanity's presence, a whisper into the depths of space. In the marriage of nanotech and robotics, in the symphony of light and energy, we craft our key to unlock the cosmos's sprawling enigma. Part 7. Embarking on the ultimate voyage, navigating life through the cosmic sea. In the realm of imagination, we've discovered a new Earth amidst the stars. Yet, before dreams turn to plans, we must confront the staggering scales of the cosmos. The planets we yearn for lie hundreds of lifetimes away, a journey no single human could complete. Enter the concept of multi-generational starships, vast vessels designed to ferry human life across the expanse of space, not within a single lifespan, but over the course of many. These behemoths of the void would cradle humans through cycles of birth, life, and death, while the stars shift and dance around them. Imagine the careful calibration such a society would necessitate. meticulous control of population growth, precise rationing of resources, each decision a delicate balance, safeguarding against overcrowding and scarcity. For a population that begins at 2000, unchecked expansion would spell doom. What should ensure survival could instead invite collapse. Another solution whispers to us from the fringe of science and medicine: the outright conquest of aging. Silicon Valley visionaries, spurred by an unquenchable thirst for innovation, are pouring fortunes into the fountain of youth. Companies like Sergey Brin's Calico, in partnership with pharmaceutical giant AbbVie, chart courses toward the seemingly impossible: a world without death. At the forefront of this scientific odyssey stands Elizabeth Blackburn, Nobel laureate and architect of our understanding of telomerase. This enzyme, with its cell-preserving power, hints at lifespans extended well beyond their current confines. And then there's resveratrol, a molecule with the potential to slow the relentless march of oxidation and aging. The quest for longevity unfurls before us, a tapestry of biology and aspiration. Yet, amidst this surge of optimism, a sea of skepticism laps at the shores of possibility. Scientists urge caution, tempering hope with the reality that immortality may be an elusive quarry, a star forever out of reach. But the human spirit is nothing if not tenacious in its quest for answers, and in the vastness of space, in the endless scroll of time, who is to say what wonders await? Part 8: Deciphering the Potential Threads of Extraterrestrial Life. Aliens, an enigma that captures the imagination, often through the lens of silver screen depictions and interstellar lore. Yet for all the fiction, the existence of intelligent life elsewhere in the universe remains a possibility, one that prompts speculation grounded in the laws of life as we understand them. Should we encounter beings from distant worlds, we might find common ground in the very fabric of existence: carbon. Its versatility in forming complex structures is unparalleled, a trait essential for encoding the blueprints of life and ensuring its continuity through reproduction. Despite the likely carbon connection, the diversity of life's chemistry could be as boundless as the universe itself. Imagine an evolutionary tapestry distinct from our own, shaped by unique worlds and their celestial idiosyncrasies. In conjecturing about alien life, we can make educated inferences, guided by the evolutionary principles that life on Earth has taught us. Communication, for example, is a universal currency among intelligent species. Whether through the modulation of sound, the nuanced dance of chemicals, or the orchestration of colors, alien beings would have developed their own methods of expression, mirroring the multitude of languages woven across our own planet. They may also share with us a trait vital for survival: stereoscopic vision. Like a hawk surveying the land or a lion stalking its prey, creatures from afar may possess eyes that pierce the veil of their environments, scanning for friend or foe. And then there is the hallmark of intelligence: tool use and environmental manipulation, a trait we associate with profound cognitive abilities. From the simplest of shelters to the grandeur of cities, the capacity to forge tools and transform landscapes is a testament to an advanced mind, whether it's nestled within a skull on Earth or cradled within an alien skull. So we stand at the precipice of the unknown, pondering whether our technological progeny may one day construct the homes of the future on alien worlds. As the cosmos unfolds its secrets, perhaps time will reveal the true extent of life's mosaic, not just on the familiar ground beneath our feet, but upon the distant soils that beckon our boundless curiosity. Final summary. In the pages of this book, we journey not just across the cosmos, but into the possibilities that beckon us beyond our warming Earth. Pollution and climate change have underscored the urgent need for alternatives to ensure the continuity of our species. Yet turning our sights to the heavens isn't merely about escape. It's an act of reaching out, of seeking new frontiers and securing second chances. Embarking on this celestial endeavor, We contemplate making our mark on the moon's dusty plains and Mars' red dunes. Before our dreams of off-world cities can be realized, though, there are leaps in technology and science we must achieve. Attaining a future amid the stars hinges on advancements in nanotechnology, which promise materials stronger than steel and ships no bigger than a thumb. Untapped potential lies within the domain of AI, where intelligent machines could construct and maintain extraterrestrial bases, becoming both the architects and caretakers of new worlds. Yet, as close as Mars and our lunar companion might appear, the universe has boundless mysteries and potential homes tucked in its starlit embrace. Our quest to populate these realms may redefine our essence, compelling us to harness our innovative spirit and teeter on the brink of the unknown. With ingenuity as our compass and resilience in our hearts, humanity's future is not confined to the cradle of Earth. It stretches out, vast and inviting, across the unfathomable distances of outer space. Thank you for joining me today on this journey of learning and discovery as we explored the insights of another thought-provoking book in our growing library of knowledge. If you've enjoyed our time together, please take a moment to follow our podcast, give us a 5-star rating, and share 20-minute books with other knowledge seekers. Your support truly means a lot. Don't forget to join me again in the next episode, where we will delve into another enriching book. Until then, happy reading and happy listening.